solve and graph each solution set. We have the compound inequality 1 is less than or equal to 3 minus 2x, and 3 minus 2x is less than or equal to 9. Because it's written in this form, we can solve, isolate x in between the inequality symbols, and essentially add or subtract or multiply or divide all three sections of this inequality by the same numbers. So let's start by subtracting 3 from here and from here and from here. 1 minus 3 would be negative 2 is less than or equal to, subtracting 3 in the middle, we just have negative 2x, and that is less than or equal to 9 minus 3, which is 6. Now, to get x by itself, I want to divide by negative 2. When I divide by negative 2, all of the inequality symbols have to change direction. So I divide this by negative 2, I get 1, and then change this to a greater than or equal to. Negative 2x divided by negative 2 would be x. Change this to a greater than or equal to sign, and 6 divided by negative 2 would be negative 3. Now that we've done this, this is correct, but it's not exactly the way we're used to seeing it. So let's rewrite this using the smaller number first. This inequality is equivalent to negative 3 is less than or equal to x, and x is less than or equal to 1. I just read it backwards and wrote it this direction. Now I'll be able to graph this pretty readily on a number line. I mark off a 0, then I mark off a 1, and a negative 3. And I'm going to, the solution is all the numbers between negative 3 and 1, including negative 3 and 1. So I use brackets there, and I shade in the number line between negative 3 and 1. The solution set can then be written in set builder notation as the set of all x such that negative 3 is less than or equal to x, and x is less than or equal to 1. Or, using interval notation, the interval from negative 3 to 1.